So I was doing a piece on explaining event modeling to people, and then decided that I wanted to show how you can use something like an event model to analyze an organization and tweak its operational structures. So I was writing an event model for development, which is now got off my screen, and realized that there are some parts missing. So when you're doing event modeling, you realize every event has an accepted, but there's also a rejected path. And so when you do an event model and you realize you only have one pathway, it tells you that something's missing, that you failed to model it. And so this made me very interested. So why is it when a product owner makes a decision to do a thing, is that they're only ever accepted by the BA? And why when the BA adds it to a backlog is it always successful? So this is a signed post to me to start thinking. The other things that I noticed in this was that there is a 6-month lead time between BA and dev. This isn't always true, but it is very often true. It's often much higher than, say, 30 days. The other thing I've noticed, because I'm a developer, I see all the failure modes of development, where tickets get rejected because complexity is too high to do at this point. Maybe you reject the BA because there's dependencies that aren't in place. Maybe there's an API key or a contract which hasn't been signed with a provider or something like that. You end up rejecting it back to the BA because the ticket hasn't been elaborated enough. There are missing requirements or the test cases aren't sufficient. Often tickets get rejected because the BA talks to some people, find out how something works, and it turns out it works completely differently in code. Or different departments behave differently, and so an assumption that's been made just doesn't carry over. Often UI and UX gets rejected because the design is incredibly hard to do based on previous decisions. And then even if the code does get deployed, it goes to QA, and the QA might reject it for all those reasons, because some developers may just be doing what they're asked to do and not really getting into, what should they be doing, right? So the QA also may be rejecting because it breaks something else completely unrelated, right? It might turn out that the UX gets rejected because the QA knows something else about the system that no one else does, because QA should get time to do exploratory testing. They're in a position of unique information because they won't always share the output for their exploratory testing because everybody else only cares about use cases being driven by the customer. And so the QA can find unusual problems, and the product owner may not know everything about the system. And then eventually there's an accepted route. The main thing here is that each role in the organization can reject a piece of work as well as accept it. And so this diagram here, it actually has all these events feeding in to these read models. And that's not shown very well. And it'd be very difficult to show an event model because we've identified that the event model has a loop, which means it's potentially never going to terminate. It's a halting problem. And we can draw this in a network diagram and represent it. So you end up with a diagram that looks a bit like this. A PO creates something, the BA approves it, it gets on and does some work, and then that work gets approved by the UX, gets on and does it, and then the dev gets some work, and then the QA gets some work and approves it, right? And each person can reject. BA can reject to a PO, the UX person to the BA or the PO, the dev to the 3 previous roles, and the QA to the 4 previous roles. And they can accept it. Now, if you assume 90% of the time it's going to be approved, by the time you get around this ring, you discover there's about a 35% chance that any piece of work will get rejected at some point. Now, that's a system that's got a hell of a lot of failures designed into it. And for me, that's really not satisfactory. It feels like we've built a system that's designed to detect failure rather than a system that's designed to build success. Right? And the other thing to bear in mind is that each one of these arrows represents a piece of time. There's time delays from transitioning from group to group to group, right? And the other thing to bear in mind is that dev has 3 arrows out of it, and QA has 4 arrows out of it, which is about half the arrows of the system. And so most of that applies after a 6-month backlog. this is like a really, really bad thing in the system. We want to fail as quick as possible, right? So, oh yeah, and additionally, right, imagine if these were teams of people that already have cross-communication with themselves, right? This is a very, very complex diagram, potentially, whereas this is like represented as being quite a cross-functional team, right? So this is like your best case scenario. The worst case is really bad. So I then like to take these things and ask, okay, cool, so I'm looking at this now and it doesn't make sense to me, but when might it make sense, right? Can we set up a team and a structure of communication where it does make sense? So here I'm imagining an actual pull-based Kanban system with sensible backlog levels, sensible, times for doing things. They may not be exactly correct, but the key things to notice is, if a BA takes 1 day to do something, then the backlog should probably be 3 times that. And I'm doing that with dev as well. There's a 20-day one there just to account for a bit of risk. Also, I'm thinking about sprints at that point. The QA is a 5-day backlog, which is half a sprint, right? On average, a piece of work will take 5 days before someone gets to it, right? And then why might it make sense to have a system that has massive amounts of rejections in it? Well, if the last step is incredibly expensive, or someone might die, say, an incredibly high cost of failure, then it would make sense to have a system that detects and rejects those failures before it gets to the incredibly expensive step. This makes sense. And then I just noticed that lots of organizations actually manufacture this themselves, because when their process goes wrong, they introduce things like a manual deploy step, and all that does is it gates lots of work, lots of value, which could have been released but isn't, into being released all at once. And so by increasing the delay for release and increasing the amount that's released, the value of that release goes up, and so the cost of failure of that release goes up. So the natural inclination to try and protect by adding more process actually rapidly increases the cost of failure. And as everyone's doing their best anyway, the more you put into it, see the 90% thing, the more likely something in that release is to fail, which will cause the whole thing to fail. So the gut instinct to protect is going to work against us all the way here. So that is when this system might make sense. But what does a normal system look like? Now, I don't work with pacemakers. I tend to work with much more web-based projects, right? A web or mobile, or things where I can release several times a day or a week. And no one dies as a result of my systems. So I don't need to have that security. But even in these organizations, normal still looks like there's a lead time of 6 months. Bear in mind, I consider a lead time to be when a PO asks for something to it being delivered, right? Or maybe the BA receiving it and looking at the request to it being actually shipped and people using it, right? And I see 6 month lead times regularly. But even if we reduce that to 30 days, everything I'm about to say is still true. And that's the backlog on dev, by the way. And if dev was taking 15 days, we'd expect to have a 45-day backlog there, which is like, in terms of working months, it's already 2 months, right? So dev has a massive backlog. Why is this? Well, we know why it is from up here. We know it's because dev is talking to PO, BA, and UI, UX, and QA is talking to all 4 roles, right? And that's why there's a big backlog. It's because developers aren't actually developing, they're figuring out what to build in order to do it. Yet this is the role of the BA in this system. So because we're modeling this as a straight line and all our things are about going in a straight line, every time there's a feedback loop, we should be highlighting that as some kind of failure, because the estimation time that dev is doing is just for the dev work. It's not really about discovering and elaborating all the other stuff. And because we know we have potentially a non-terminating system because of all the loops in it, it means that we have a very, very long tail. And so if we really are wanting just to put estimates around dev and QA, then we need to do that on a ticket-by-ticket basis, and going out and changing a ticket after it's been estimated means the ticket should be rejected as a failed change request. So now if you take the accelerate metrics, the DevOps things of lead time, change frequency, change failure rate, and deploy frequency, then you realize that we can move them, we can fold left, we can go further out and apply these metrics elsewhere to get a good idea of health. And And so we want to measure the change failure rate, because if we have a process that assumes a BA can give dev ticket and the dev can go off and do it, we need to know if that's not true. And we all know it isn't. It is not true, right? And so by doing that, it makes it visible. And now the BA is a bit unhappy because it looks like the BA is doing stuff wrong. But it needs to be known that the BA can't help but get stuff wrong, because the BA doesn't have all the information the BA needs to do the job. Okay, so the BA now gets dev involved so they can help. And so this usually involves the most senior dev. You'll often see like principals and stuff in this role, and then they'll sit with the BA all the time, and they'll effectively pair on producing tickets. And this will involve the most senior dev going off and looking in the code base, figuring out how to do a piece of work, and then updating that in the ticket and elaborating it, right? Well, it turns out that the dev time doesn't actually go down very much, because now the dev team doesn't have the most senior dev to talk to. When the dev who is going to do the work, which is always different to the person elaborating it, they still have to go through the code themselves, figure it all out, work it all out, and it takes ages. It's still a very, very hard piece of work. So, while advantages are gained from reducing rework, the cost is your dev team is one shot, and most teams will be about 8 people big, say. There'll be a PO in the team, there'll be a BA in the team, there'll be a QA in the team, there's probably a UX person in the team, which only leaves 4 developers. Let's say 5 and be generous. Well, you're taking 20% of the team away at this point, which in a sprint, that's the equivalent of 2 days worth of work. So that's quite a lot, right? So does it compensate? Well, not really. And as a result, a lot of teams that do this middle role still employ an idea of free amigos, where the QA, the BA, and the dev get together and they further elaborate the ticket after estimation just before the dev picks it up. So we're processing harder to try and fix a process. And even though these particular moves are quite good, they're still like throwing good stones after bad, right? So what we've done here really is tweak the probabilities, and we make quite a big difference on the probabilities. The probability probably goes up to like 95 or 98%, but you still have rejections, you still have the basic same network, but now you've introduced this node in the middle, but things can't reject onto that node, so it's quite good, and it reduces the probabilities, but the costs go up still. So we have another scenario, right? Well, eventually, dev and QA get annoyed with each other. Dev gets annoyed because QA keeps rejecting work for stuff that they couldn't have known about, and it's frustrating. And the QA gets annoyed with dev because they keep having to reject work. And the QA gets annoyed with dev for this because it makes everybody look bad, right? Because this ticket is now it's taken 6 months. There's tremendous time pressure, despite the fact it's only actually taken like 10 days of development to do it. For some reason, everyone really cares when you're 2 days late on a 6-month ticket, right? So we have to get this stuff right. And whenever QA rejects a ticket, you then get into this argument about, like, should it be a new ticket? Should it go into the original ticket? Is it still part of the QA backlog? Is the lead time on this ticket that the QA was meant to spend a day on a thing? Everyone regards this now as a failure because the QA's found the problem before it gets the reduction, right? The fact that we've just stopped something bad going live becomes like less important than the fact that something is now late, even though it's 6 months plus 10 days away from it. So eventually dev and QA realize that actually they all just want the same thing. They sit down next to each other, they start working, and some magical things happen. First of all, it should be noted that the backlog for QA no longer exists. Right? So that's 5 days of wait time there gone immediately. And no one's changed how they're working it, right? Well, they have, they're sat next to each other. But there's other positive effects that come from this, right? The change failure rate should drop, because if the QA can't reject the dev work because they're working alongside each other, that means that the work coming out of the dev and the QA will have a much higher quality, right? So we get rid of the backlog, which allows work to be released 5 days earlier automatically. And 5 days earlier is effectively the cost of the entire development team saved, plus the opportunity cost of that piece of work, which should be worth more than the development team. Otherwise, you wouldn't be paying to build it in the first place, right? There's less operational expense because you get less of the the communication, like coordination costs, because of the delays between dev and thing communicating the tickets and the boards. And it turns out that QA's output was dependent on dev's output anyway. In fact, the only reason why the lead time of 5 days appeared is because they were using Scrum, and it meant that like they were getting these huge lumps of code being passed over at the end of every 2 weeks instead of a nice trickle of constant demand, right? So by pairing, you fix all those problems at once. There's no sudden slews of huge amounts of code, and things start to flow, right? And because QA, it wasn't constrained by development in the first place, whereas development is the bottleneck of the system, everyone has time and everybody works. So dev and QA get on like a house on fire, and they begin to realize that maybe there's opportunities to do this elsewhere, right? So now they go off and they find the BA, right? And they're like, do you realize you have a 6-month backlog? And the BA just goes, so what? They don't understand what the problem is. Well, we just save 5 days of development time. And the BA goes, so what? And it's like, well, if you measured this in terms of cost of delay, we've managed to get to market quicker. And the BA still says, so what? Because BAs don't think about revenue anymore. But what we can do is then start working with them more. So let's suggest a new way of working, right? Let's delete the backlog and let's start again. Because it turns out that when the dev picks up the ticket, they're going to sit down with the BA and go through all the analysis. And it turns out that like the time for the BA to analyze this stuff is a tiny fraction of the 6 months that was in the backlog. So this means that we can do it like just in time. And while doing it, the dev and the QA can inform them on how the ticket structure should work, right? And so this means that not only is the BA able to get that senior dev kind of input from both a QA and a dev at the same time, it means the person who's going to be doing the work is also present in that conversation, and it's all feeding back on itself, right? It's mind-blowing. Even if this process adds 2 days onto the development of the ticket, because we've got rid of this 6-month backlog and we're just working on things as they come, well, we're still saving a fortune in time. An absolute fortune. So we don't have any rework now because it's all being done at the same time with the people that need to ask the questions to. We don't have to protect this doomed process by introducing new roles. Everybody's required, is present, and they're collaborating. And the BA feels like they're wasting time here because now they're spending more time per ticket. But what they don't see is all the time they're saving downstream of development rework time, development having to go and ask questions. And bear in mind, development's on the bottleneck, so any time they spend is actually directly related to revenue. And so by saving that time, and so by the BA taking action like this to save time, that means actually the BA's helping achieve whatever money will be made off that directly. And the same is true for the QA. If the BA can stop the QA from having to do rework, well, because the rework happens after the bottleneck and will bounce back up to the BA anyway, that rework will go through the dev team and add to their load. So this whole process is acting to help systems downstream of the bottleneck, which means that effectively the BA choosing to change the way they're working is supporting the bottleneck, and so any gains can be attributed, the gains from that change can be attributed actually directly to the BA, which is huge. And so now we're getting this game, right? Now we have like maybe a 30-day backlog that's like just the PO like suggesting things, and we sort of ignore them, tell them to put it on the list, right? And then we have a dev and a QA and a BA, and now estimation happens around all of it. They pick up a ticket and they can go, I think that's quite big, I think that's 2 sprints, right? And then we can trim it down into pieces of work. And now all of a sudden stories and work and stuff is related back up to these high-level things instead of these small chopped down things, which is what happens here. And our estimates cover the entire process, which means all the games before about trying to, keep things small or moving or accurate, and like the little sub games you play in shipping work across the board become less valuable. You can focus much more on the fact that the PO is asking for something for a business need, and this can be shipped out the other side of it. So it gets super powerful. So now we can suggest a new way of working with a product owner, which is don't tell us things to do, because this relates back up to the original failure mode on the event model, right? Because the PO is asking for a thing, it's possible to ask for a thing that doesn't make sense, and things can be rejected. But if the decision data comes from customer demands and organizational goals, well then the product owner should really be asking for an outcome such as increased, I don't know, conversion, revenue, happiness, right? And so this allows you to have a very different view of the world. It allows the product owner to say, put out the fires, or like, we think we can increase conversion, and so increase revenue by X per thing. And then you can say, please help me do that. And now you can ask, how long do you want to spend on the problem? The PO says, oh, about 2 weeks. And we say, sure thing. And to the rest of the world, it looks like we're still doing sprints. But the outcome's incredibly different, because now we're free to solve that in many different ways. And we're free to actually propose solutions and execute them with like no lead time, because we don't have a 6-month backlog, which means something which on average might take 6 to 10 days very often can be done in half a day out to production, and you can be back asking for what's the next most important urgent thing. And when you get to this is what I ended up giving a talk about called Leroy-driven development. But really it's just a restatement of extreme programming with some sort of more modern ideas in it. You know, this idea of keeping a backlog to absolute minimum, dealing with outcomes by making tiny changes and like having fast feedback on experiments. It's about large amounts of automation. So all your business requirements would be automated by tests, because the one thing you can't do is violate them. You know, you're testing outside in, you're automating this, you're automating deployment all the way to production, because whenever there's a reason not to deploy something or something failed in production, you're turning that into a test. And so you end up being incredibly safe, to the point that on teams where I've done this with, we've ended up pushing straight to master, because we're going to go out and automate all the way to production anyway. We're pushing to master because when the build goes red, someone wants to fix it, right? Everyone swarms on fixing the build, because we're doing things in the most important urgent order. We know any work that was done in the past is the most important urgent thing, and the stuff we're doing now must be less so. So that allows us to fix it. And even if it's not, guess what? The thing that we're doing now is, and that's blocking us from doing it. So it's a dependency that needs fixing. So no matter what, we can push to master, and we can always pull from the head. Our change failure rates end up being incredibly low because of the level of automation, to the point that I think my change failure rate while doing this is lower than people doing feature branches, which is ironic, because people do feature branches because they're afraid of pushing stuff out that doesn't work. It turns out that prop of a feature branch ends up being a prop of not properly testing and integrating with everybody, and then you find out the bad news too late. So in summary, what I want to say is I took that event model, I've looked at it, I noticed some gaps, it felt strange, I've analysed it by doing a network diagram, I've then sat down, looked at the flows of stuff and the way the information's moving through the system, I've decided parts of it are insane, and I've remodeled the system to try and solve for various constraints in the system, namely the development team. I've subordinated the entire system to the development team, which means that the BA and the QA teams, the non-bottleneck teams, work in lockstep with the development team, that is the bottleneck. And incidentally, if other parts of the system were the bottleneck, for instance, the BA couldn't analyze stuff quick enough and the development team was overachieving, guess what the answer to that is? Well, you do the same thing. You subordinate the system to the BA team. Devs and other roles start performing more BA-like activities, and you end up with the same shape of this anyway. So now what we have is 2 sets of inputs, at least. Customer demand, organizational goal set, which leads to decision data. So the PA now goes, well, okay, I want to spend Y time to deliver outcome X. The outcome gets accepted. It could get rejected, I guess. I still haven't modeled that very well. But the point is, the team gets outcomes to deliver. They ship some stuff, and now they can directly measure whether the outcome was hit or not. No matter what that is, that either feeds back into development if there's still time in the window, or it feeds back into the PO to identify new customer demands. And this all comes back to the notion that team is an indivisible unit, and that's a Matthew Skelton quote. I mean, it is true for this, but the PO is technically part of the team, and the team should entirely own its product, but that's a different story for a different day. I found this approach works particularly well for value stream aligned teams. There are other kinds of team which I still think it probably applies to, but every idea has its limits, right? And I think this approach hits its limit when you need absolute certainty that what you're delivering isn't going to kill someone. In all other situations, you should be trying to reduce the cost of delivery to the point that you can deliver very quickly and safely. And this goes back to Simplicity and Rich Hickey, where he ends up claiming that the agility of simplicity dominates all. And this is the same sort of thing. It's about taking a complex system that's designed to give you a hard time and redesign it into something very simple. Cool. That's it. Thank you. Bye.